This fun problem comes from the channel Mind Your Decisions. I'll put a link in the description. It gives us a square with sides length 1 and a semicircle on the bottom with radius 1/2. It asks us to find the length of this line extending from the top left-hand corner through the tangent point inside the box. Let me stop so you can pause the video and work on your solution before showing you how I solved it. The first thing I want to do in solving this problem is to break the blue line up into two parts. I'll draw this red part and call it L1 from the top left to the tangent point, and then this green line which extends the rest of the way from the tangent inside the box. We'll call that L2, so that our length L is the sum of those two things. Now let me draw another red line from the top left corner where the first red line starts down to this other tangent point. With either a symmetry argument or geometry, you can show that those two red lines have the same length. They're both 1. So our length L is now 1 plus L2. I'll find L2 using similar triangles. Let me first draw this reference line from the center of the circle up through the tangent point and call that angle theta. These are right angles, so you can show that this angle is theta, which means that this angle up here is also theta. Now let me draw two similar triangles in orange. Here's one of them, and the other triangle is this one. Because these triangles are similar, we can equate ratios of their sides. I'm going to equate the ratio of their hypotenuse to the side opposite the angle theta. For the large triangle, the hypotenuse is L1, and the side opposite the angle theta is 1/2 plus 1/2 cosine theta. That's illustrated here. 1/2 plus 1/2 cosine theta. That equals the same ratio for the small triangle. The hypotenuse is L2, the length we're looking for, and the side opposite the angle theta is 1/2 minus 1/2 cosine theta. That's illustrated here, 1/2 minus the length to the left of this dashed line, 1/2 cosine theta. We know that L1 equals 1, and we can cancel all of the 1/2s to find that L2 is 1 minus cosine theta over 1 plus cosine theta. Substituting that into our expression above and simplifying gives us L equal to 2 over 1 plus cosine of theta. We don't know cosine of theta, but we can find it using one more right triangle. I'll draw it here in light blue, extending from the top left corner to the center of the circle, so that this angle is theta over 2. Cosine of theta over 2 is the adjacent side, 1, over the hypotenuse. We can work out the hypotenuse of this right triangle using the Pythagorean theorem, and it equals the square root of 5/4. Now, we don't need to know the cosine of theta over 2, we need the cosine of theta. So I'll find that using the double angle formula. Here I've written it in terms of phi and 2 phi, but what we want is the same equation written in terms of theta over 2 and theta. We know that cosine squared, theta over 2, is 4/5, so that tells us that cosine of theta is 3/5. We can substitute that above to see that the length L is 2 over 8/5, which reduces to 1 1/4. That's the length of our original line.